Okay, so let's look at pKa of amino acids. And let's see here. Let's take a look here. Maybe this one. Okay, so let's see. For histidine, the pKa's are 1.82, 9.17, and 6.04. And for lysine, it's 2.18, 8.95, and 10.79. Now, before we start, let me say that this is the general structure of an amino acid. So it's this structure here. We have the amino group. Okay, so I'm going to draw it this way. Okay, so these two protons circled are the protons which are donated by the amino acid. So for example, for histidine, it says alpha CO2H. So note that at 1.82, this one, the pKa of this one is, for histidine is 1.82. And then it says for the alpha NH3 plus, for histidine is 9.17, so for this one, this is 9.17. Then for the side chain, they're showing the side chain for histidine. It looks like this thing here. Okay, so in your textbook it also shows it. Okay, so let's write this down. For histidine, let's see, so that's going to look like, let's see, a CH2 group, so CH2, and then it shows this ring, so carbon double bond to another carbon. Let's see. Okay, so it turns out that for the third pKa, it's this one. And this one has a pKa, according to the table, of 6.04. Okay, so let's do the same thing for lysine. So for lysine, sorry, look at this. No, we have to switch this over. This is actually histidine, so let's change this. Make this histidine. It's easier to change the name than to move the structure over there. Okay, that's histidine. And for lysine, okay, so here's the structure. Okay, so for lysine, the acid group has a pK of 2.18, so this is 2.18 here. And then for the amino group, it's 8.95. And then for the side chain, they show this long side chain. Let's see. There's, let's see, 1, 2, 3, 4. So 4 carbons and then an amine group. Okay, so for one of these protons, the pKa is 10.79. Okay, so what this half of the class do is to draw the titration curve for lysine. I like this half of the class to draw the titration curve for histidine. figure out the pH at each endpoint and each halfway point. I encourage you to work together. Actually, I want you guys to work together this week because we're going to, I think we're running out of time. Yeah, we have 15 minutes left in class. So let's try to get this one done today. Now first, what type of acid is histidine? Is it a monoprotic, diprotic, or triprotic acid? Yeah, this is triprotic, so how many endpoints are we going to see? Yeah, 3. And for lysine, is it mono, di, or tri? Okay, so we'll see how many endpoints there. Yeah, 3.
Did you want us to find all the pHs?
Now remember, when you do calculate the pHs, note that at the first and second endpoint, it's pretty easy. Just use this formula. And at the halfway point, remember that pH equals pKa. Okay? So really there's only 2 calculations to do at the starting point and then at the third endpoint.
So what do we use for the initial amount of the amino acid?
Just use 20 mils of 0.1 molar. Okay, so on your titration curve of lysine, what is the pH at the first halfway point? It should be at 2.18. And at the second halfway point, it should be at 8.95. And at the third halfway point, it should be at 10.79. And at the first end point, it should be 5.57. And at the second end point, it should be, what was it, 9.87. So now we've got to calculate at the initial starting point at the third end point. And while you're doing that, let's go over here for this side. So at the first halfway point, the pH is equal to 1.82. At the second halfway point is equal to 6.04. At the third halfway point, 9.17. At the first end point, 3.9.
We go 4.
3.93, okay. At the second half, sorry, the second endpoint is going to be 7.61. Okay, so now we got to calculate the starting point and at the third endpoint. Okay, now this is where charge comes in. So let's take a look at lysine. Note that the structure shown here is the fully protonated form. So at low pH where there's a lot of H plus present, this should be in the acid form. Okay, so what's the charge here of this? What's the charge of this entire amino acid, the way it's drawn? Okay, because now we have a plus charge on this nitrogen, a plus charge on that one, and a no charge here. So